Hi, this is Brian Heron. Thanks for joining me today. Today, I have the opportunity to talk about OBD, some of the nuances about it, and how it's used in the automotive industry. So, we'll talk about a wide range of topics from what OBD is and isn't, how it's used across the industry, its evolution over the years. We'll also talk about some of the new technologies and their impact, like CAN, and DoIP, and what that means for diagnostics and programming. By the end of the session, you should have a good understanding of these base concepts. Now, I want you to think about diagnostics, especially when you're a SEMA member and you're in the aftermarket. You need a diagnostic interface, even if you're not fixing cars, but you're customizing cars, because diagnostics is really how you can tell how that vehicle's operating. If you're connected to a vehicle and you're looking at the data and the systems and you bolt a part on or you make a custom part, you need the diagnostics to tell you, is this vehicle operating as it should be? Am I putting any lights on the dash? Are there any trouble codes that are being induced by my modifications? And all of that maybe 20 years ago didn't matter so much, but now as we have ADAS and complicated systems on vehicles, it really is important that as you customize vehicles, you understand the impact on how the vehicle drives. Okay, we're going to jump in here. So what is OBD? Obviously, it means onboard diagnostics, and it's really a collection of networked computer systems. In the early days, you had maybe an ECU for just engine management, and then transmissions became electronic. So you added a TCU, and then you added a body control module, and then power steering and ABS and traction control. And now we have all these ADAS systems. So there's just all of these different systems that are on cars. And OBD is really a methodology to retrieve data, diagnostic data from these systems. And SAE and ISO are both big players in the OBD systems. SAE predominantly is US, ISO is predominantly European, although that's not across the board true. And there's many different standards. I mean, there's a huge collection of standards that drive OBD. So what you need to understand is that um, OBD does not guarantee you access to everything. Just because you plug into an OBD port or you have an OBD tool does not mean that you have everything you need to get into the entire vehicle. In fact, um, right to repair was all around access to dealer diagnostic systems to get the same level of access that car dealers have. Even at the dealership level, they're not necessarily seeing all of the data that's in that car. They're seeing what that tool was designed to give them. OBD is also not a prescriptive way to hand you a diagnostic for a car. It doesn't tell you what's wrong with the car. It doesn't um, give you any guidance on what to do. It's simply the data that's in the vehicle and tests and codes and controls that are all accessible through the standards of OBD. It's also not a conspiracy by the OEMs to lock out vehicle manufacturers or independents. In fact, OBD was actually created for emissions testing standards. And it goes all the way back to pre-1996. As cars were having catalytic converters, they wanted to add a standard so they could test and see if the emission systems were working properly. Now, look what's happened. The emission systems are less and less as vehicles are more clean. Some of them are EV, yet OBD still persists because now we want to have diagnostics of the operability of the vehicle, the safety systems, maintenance. There's just so many things that come out of OBD these days. So what is it really? Like I said, it was really driven by emissions with EPA and CARB. OBD2 is a J1962 connector. Now that's another SAE standard. And the J1962 is the 16-pin connector. Now, when vehicles were first sold, not all of these pins were used. In fact, it was early protocols only had a few of these things. And then as vehicle complexity increased into the 2000s, the CAN bus was added, replacing some of the older serial K-line buses, replacing J1850. So CAN became fairly standardized at first. We'll talk more about what's happening next there. So really, it was a standard set of pins and protocols. It was also a standard communications and message structures. They set up a standard set of modes where you can get sort of emissions and basic data out of it. But those modes don't necessarily tell you what you might want to know. It might tell you things like the freeze frame data for the vehicle, or just RPM and engine speed, and very basic things are fairly standardized. But for example, if you want to know the fuel level in a vehicle or the odometer, those are not accessible through the 10 modes. Now you get into manufacturer specific and enhanced data. So again, these 16 pins is where the data was originally designed to come from, especially for emissions testing. And then the types of data and the modules behind it do vary by car. And you get a code here like this PO 420-27. Well, what does that mean? So the OBD structures first are around the type of code. So you have P for powertrain, C for chassis, B for body, a U for a network code. And then it's the type of code. So those 0, 1, 2, and 3. And then it's the system and the component, and then the system bytes. So all of these different things describe the type of code, and you can see literally how many combinations of codes you could have based on this. But just by looking at it from a P code, well, okay, now we know it's a powertrain code, and it's 420, so we know that it's an aux emission system, and 20 is the component. And then there's the symptom bytes, which give you even more detail, which in this day and age, having a P code is incredibly useful. You can access service information. You can look on Google. You can even use AI now with things like ChatGPT to put in these codes, and it will help you to understand what it means and where you might look to understand what the code is all about. So why the J1962? Well, you have to kind of step back to pre-1996 and the early days of OBD. They were just putting connectors on cars that each manufacturer had their own style of connector. They had their own pins, they had their own voltage, they had their own communications protocols. And because of the OBD emissions requirement, it said, all right, we're going to go to a standard set of pins and standard communications. So that was 1996. Then in 2008, it really started around 2003, 2004. I think the first CAN vehicle I saw was 03, a Ford Explorer with the PTAC module. They started moving to CAN on 6 and 14, which was a standardized bus, fairly high throughput at the time. And that became the standard in 2008. Now, it didn't become the only protocol in 2008. It was required for emissions testing, but we still saw K-line and J1850 and some of the legacy things all the way through. And in fact, today there may still be some of that. I know, like at 2018 model year vehicles, we still saw a J1850 on some vehicles. Incredible. So then 2022 comes around, and what you see is the CAN bus just it's not fast enough because we have ADAS systems and we have high-speed data moving through these vehicles, and you need to move faster than 500K, which was the limitation to CAN. That's when CAN FD got introduced. And in addition to that, DoIP also came around. I'm going to talk more about that in just a little bit. So CAN FD allowed you to go at a faster speed, where the previous CAN 2.0 could only take you, oops, slid backwards there, to 500K. The new CAN could handle up to 64 data bytes per frame, so it could hold more data, and it could move all the way up to theoretically 8 megabytes or beyond, which really allowed us to think about 500K before. Now, this is moving a lot faster through the same twisted pair wire set. So it brought a lot more performance as, the features of a vehicle just increased. So then, CAN's out there, and that's great, but what do we do about, we're moving towards autonomous cars, we're moving towards imaging on vehicles, so we have 360 cameras, we have LiDAR. We can't move that much data through the bus. So BMW had Ethernet early on in vehicles, and then additional manufacturers started to add Ethernet on the OBD pins. And so there was an ISO standard, it's ISO 13400, which was the beginning of Ethernet assigned to the OBD pins. And now there's a few different variations of Ethernet on the OBD pins, but now we're moving into 100 base TX on the vehicle connector. We even see a few vehicles that were pure EV, that put Ethernet outside of the vehicle connector. Tesla, for example, some Teslas have the OBD connector, some do not. They have the Tesla connector, and the OBD connector is only required for vehicles that have internal combustion engines. So if it's a pure EV, then all bets are off at this point until future legislation may change that at some point. So now you can see how they coexist. You see this 2015 vehicle had K-line, it had Ethernet on it, it had a lot of different things connected up to this. So what's happening here, and this is in the 2010s to 2020 era, even through today, is you used to just have a CAN vehicle network or a K-line vehicle connector through a normal VCI, and that connects to your diagnostic tool. Now, the direction we're headed here is that we have now the OBD, which could be CAN or DoIP, and until the federal emission standards move completely off of CAN for emissions testing, which they haven't done yet. They're just moving to UDS. It's going to be a period of time before CAN completely goes away. But no, just because a vehicle has CAN bus doesn't mean you can access everything on it. OBD for emissions only requires emissions access. So it's pretty critical that as we move into the future, diagnostic tools and testers have Ethernet, because a lot of vehicles are moving towards Ethernet. So now you can see in the Ethernet world, you have many different connectivity ways to get there, whether it's wired or wirelessly or direct connected LAN to the vehicle. So this just shows the architecture of a VCI and a CAN, and you see GW, that's gateway. I'm going to talk a little bit about gateways, but it's essentially like a firewall or a router that you connect to, and from the gateway, you then have access behind it into subnets and subnetworks of different vehicle architecture. So you can see this particular example has CAN on 2 different buses. It has FlexRay. It also has LIN on an ECU to ECU approach. So this is pretty traditional. And this is one of the cleaner architecture diagrams I've seen. Some can have 30 to 50 ECUs and lots of different wiring going on. So now we move to Ethernet, and it allows a direct connection from the vehicle straight to the diagnostic tester. And notice this is not showing the physical connector, whether it's on the OBD connector or not, but Ethernet now gives you a direct connection straight into the vehicle. And then what happens is Ethernet goes through the gateway, and this is what DoIP is really starting to look like in a lot of modern vehicle implementations. Fiat Chrysler was the first to put a gateway on. And what the gateway means in the simplest terms is it's authentication into the car. So prior to gateways, you could communicate directly with ECUs, and you could unlock them if it was a secure module and you were doing some kind of reprogramming. You could send direct messages to it. But now with a gateway, you actually have to authenticate through the gateway to get permission to access the ECU, and it facilitates that communication. So that's how it looks. And then you can see here, this little drawing shows the switch showing the different ECUs and how the gateway manages the access between them. And gateways are really important for you as a SEMA member to understand, what does that mean? Why are gateways important? Well, as vehicle complexity is growing and these gateways are growing, you have to get permission to access the gateway. And one way to do it is to get a factory diagnostic tool. Like if it's Chrysler, you're going to get a YTech tool. If it's GM, you're going to get TechLine Connect. And so when you use the factory diagnostic tool, assuming you have credentials into the tool, they basically authenticate themselves through it, because that's the same tool the dealerships use. Now, if you want to use a multi-branded or an aftermarket tool and have access into the vehicle, that's where secure gateways become pretty critical, because OEMs have to grant your tool provider access. Let's say you make a diagnostic tool. You can't just open the gateway up. You have to go through a secure process to authenticate in, and it's pretty high complicated security. So it's not like you're just going to hack right through the gateways. In fact, one scan tool manufacturer made a cable that plugged in behind the gateway. So you could skip around the gateway, but now a lot of the communications behind the gateways are encrypted. So that was just a short-term shortcut. Now you can't really do that anymore. But what I want to say here is these gateways are a key part of the future access to vehicle protocols and vehicle communication. So if you want to customize a vehicle, you just need to understand that vehicles are getting gateways. Gateways require authentication. So as a SEMA member and as a user, you need to make sure that we're protecting our right to have access through that gateway and to do vehicle diagnostics or to look at the vehicle data as we're customizing and modifying cars. We want to make sure that they still operate as they were intended to. So that's one point I want to make in here. Gateways are a big deal, and not every vehicle has a gateway today. Several brands do. There's no doubt in my mind that within 5 years, pretty much everything new is going to have some type of gateway. Now, also in Europe, there's a big battle over whether or not gateways are legal, because the European Court of Justice has said they're not. So there's a number of organizations and OEMs trying to solve if a gateway is allowed or not. Keep an eye on that. So this is a different sort of overview of how diagnostic connections in the future could work. Again, you've got your gateway plugged into everything in the vehicle. It's accessing all of the different vehicle ECUs through the gateway, and then it could be activating DoIP, or it could also be going over CAN or CAN FD. And it's possible the gateway could manage through multiple different communications methodologies, the same messaging, whether it's USB or Bluetooth or Wi-Fi or CAN or Ethernet, or I don't know, pick your protocol, smoke signals. The gateway is basically going to allow you to communicate and manage all of that for you. So another thing I want to talk about just briefly is diagnostics versus programming. So many OEMs are starting to use this CAN-FD for normal data, which is just diagnostic codes and things. But a DoIP is, again, I talked about it before, for high bandwidth situations where you need to move a lot of data. DoIP becomes really useful. Now, in some of these more modern vehicles that have infotainment systems, and we're starting to approach level 3 autonomous driving, now we're going to move not just bytes, but megabytes and gigabytes of data into an ECU for reprogramming. That's where, again, the DoIP and Ethernet become really useful because you're moving a lot of data. It could take you not just minutes, but hours to do under a CAN connection. So I talked about this a little bit before. I want to just show you a diagram of what secure gateway looks like and why it's important. So what you're seeing below is the authentication of the secure gateway access. The way it works, if you get a diagnostic tool, is you have to have credentials for access through the secure gateway. So an aftermarket tool vendor has to support the secure gateway access, and in real time, as they're connecting to the vehicle, they need to run your credentials through a secure bridge server or some type of authentication system to grant you access into that vehicle to have a diagnostic session. Now, Right to Repair talks about a standardization of secure gateway authentication. That 2020 law it was passed as a referendum, but it's been challenged and it's in court. So there really isn't an outcome of that. NASTF is involved in LSID, which is a locksmith authentication. And there's a number of different parties involved, ETIs involved, ISSs involved with the authentication. So depending on where you are in this value chain, if you're just trying to get a tool and access a vehicle, what you need to know is that you'll have to have credentials into that vehicle. If you're trying to build a tool, you need to understand how to set up this whole infrastructure so you can authenticate your tool through. And if you're a dealer or if you're using OE tools, typically that's already managed and taken care of for you. So there's another dimension to this, which is SOVD. And I want to talk about this briefly because this is a new concept that's emerging. And the way I describe this to some people is in telematics, there was a direct access called SVI, and there was a manufacturer portal called extended vehicle. I like to think of SOVD as kind of like extended vehicle, but it's in the car. Because what SOVD essentially does is it creates a layer between you and the gateway, and it can give you diagnostic services and access to things. It could even sort of abstract out some of the complexities of how you communicate with a vehicle ECU. But on the other hand, it could also become a firewall for direct communications. And one of the upsides to SOVD is that it simplifies diagnostics. One of the downsides is that it's a question mark of whether or not in an SOVD world, you'll still be able to have a direct authentication from a diagnostic tester to a diagnostic tool on the other side and be able to send your own CAN messages. It's being talked about both ways, whether it's going to be allowed or not allowed. I think will just come down to where the industry goes. But it's a very interesting concept, and it is definitely poised to change how access occurs. Gateway was kind of the first step, and SOVD is kind of the next layer. There's high traction within the automakers to move this direction. So I think there's no doubt that we're going to see SOVD implementations, and we might see a lot of it in the future. So you can see here, this is just a simple chart of how UDS diagnostics is kind of the current generation of diagnostic messaging, and how SOVD is going to start to be alongside UDS, and then eventually the UDS may go away and be replaced by SOVD. And that's the scenario where you think about how are you going to have direct vehicle communications access in a pure SOVD world? Just something to think about. So this was pretty technical, and I apologize, but this was also titled as the sort of vehicle communication side of diagnostics. And if I lost you in this, I apologize. I'll have other sessions in the future, hopefully, where we can talk more about high level. What does this mean for SEMA members? But this is really the building blocks of how you communicate with a car and what's inside of its network. And the network is ever changing. Um, Access is key here. And then understanding the data that comes out of the vehicle is also really important. So is you're buying tools to do diagnostics so you can understand how you can customize your car or build parts. You need to understand what secure gateways are and access through, the credentials are, and also what kind of vehicle you're communicating with, because you could buy a diagnostic tool that does not have DoIP or a new technology on it, and it may not be compatible. Also understand when you buy diagnostic tools, it doesn't mean you get everything. I think that's the number one question when somebody enters this world and they look at diagnostics. They think that it's all figured out, and you can buy any tool out there, and you can just know what's inside of the car, and you can change things whenever you want. And it's a very complex world. It doesn't work that way. Some brands of tools are good for certain brands of car, like maybe it's a European specialized tool, or it's a, American brand specialized tool. So the brand of tool you use is going to make a difference. You can use the dealership diagnostic tools that Right to Repair grants you access to, which is essentially what the dealer has, but it only works on one brand. And you will have to buy a subscription, in fact, for that tool. And it could be a daily, a monthly, or a yearly subscription. Some manufacturers make it very easy. You can go on the website and have access with a J2534 tool, like is pictured here, within minutes, maybe hours, depending on your first time through. There are other manufacturers that require you to fill out a form, submit it in, wait for approval, and it could take you weeks to have access to the OEM diagnostic tools. That's why the aftermarket multi-branded tools are so convenient. You can just pick them up from places like Amazon or a Snap-on tool truck and connect to the vehicle. But every one of them is different and has different, ups and downsides. So I think I want to tie this together and say thank you for coming to this presentation. I wish I had a couple of hours so we could really dive deep on this, and that would just cover vehicle communications. It won't talk about how to use the data as you modify cars. SEMA's done a lot of great things with the SEMA Garage, talking about how ADAS systems work. There's a white paper out there that just kind of scratches the surface of where we're headed next. So I think on that note, I'm going to wrap this up and open up the session for any questions that you may have. And thank you very much, everybody.